Hello everyone, my name is Joel Dunay and I would like to show you my official unofficial network state exam solutions. Now is the second topic, which is about iOS OSI based network systems. Why do we use layered architecture of the communication? I already talked about this in the previous one, so I'm not going to repeat myself here. Please check the previous one. The layers of the OSI network model and their roles, I partially talked about this in the previous one, but I'm going to do it again in this case because we have these 7 layers, and which is important. I didn't talk about every in the first one. So we have the 7 layers. If we go from top to down, then we have the application layer, which layer that actually the user use. For example, sending an email from host A to host B. This is a good example. In this case, data will be generated in the application layer. This data is passed down to the representation layer. The representation layer simply stands for common representation for the user, so it will readable for human. And then that data will be passed down to the session layer, because the session handler handling the session is really important, because there can be multiple applications that are simultaneously talking. Therefore, we have to identify that which packets belonging to which sessions, and the session handling will help with this. The transport layer, as I said, helping to handle the sessions based on the source and source MAC address and source IP address, and the destination MAC address and destination IP address, because these two are creating two pairs, and these two pairs are defining that which traffic belongs to which session. That's why, for example, we are talking about a stateful layer, because it handles the sessions, or at least the TCP handles. Then this will be about the PDU. I will not talk. I talked that about in the previous one. About yeah, that's them, and the main services, main protocols. So at the transport layer, we have to mention, of course, the UDP and TCP here. There will be a single topic about these two, so I'm not going to tell it here. I will tell it there, and then you can tell it here if they want, but I don't think they want to hear about the TCP and UDP here. Of course, this data will be passed down with the transport header to the network layer, where a network header will be added. The network of I forgot to say in the previous one that, of course, the transport layer stands for segmentation, to segmenting up the data. Of course, the TCP can, for example, provide flow control as well, but mainly the session handling and the segmentation is the main approach of the transport layer. The network layer uses the layer 3, so we are talking about routers. The network layer uses the internet protocol as a source and destination IP, and based on them, the routers are using their routing tables to forward the traffic from one network to another or to a destination. So of course there does encapsulation and de-encapsulation. Then it will be passed down to the data link layer that I've said it has two sub-layers, the logical and the MAC, which is the hardware, and the previous one is the software. We need an interface between them to work correctly, and the main important part here is the error detection, that it does error detection in the trailer, and it has a start of the frame, which is the preamble, which stands for synchronization, that I will talk in later topics or topic. The similarities and differences of the TCP/IP and OSI model. The TCP/IP stands for Transmission Control Protocol, and Internet Protocol model. So we can define the TCP/IP model with the help of the OSI model, because the TCP/IP uses exactly the same layers but defines in another name them with another name these layers. So at the TCP/IP, the application, the representation, the session layer is called as the application layer because this layer is the closest to the user. This layer uses simply the data that's generated by the user. Then the transport layer is directly mapped to from the OSI layer to the TCP/IP model and does exactly the same. The network layer is the same, it's directly mapped, but it's called as internet, and the physical and data link layer is called as network access layer in the TCP/IP model. So the similarities, you can tell that all the layers does exactly the same, and the PDU and everything else are the same. The only difference between the two models that the TCP/IP model does not define. The TCP/IP model only defines the handoff of a packet from the internet to the network access layer. Meanwhile, the OSI layer, physical layer, also defines the electrical, procedural, and other means for bit transmissions at the physical layers. So that's the differences. And that's all about the second topic. Again, if I said something wrong, then I don't really care. And don't forget to subscribe to my channel.